Bismillahirrahmanirrahim. Let's get started with the name of Allah, who is the most beneficial and the most merciful. Assalamu alaikum, and I am warmly welcome to you on this channel. I am going to share solution of Physics Grade 9 Cantab Publisher. If you really want its solution, you are on the right place. This video is based on Test Yourself problems of chapter number 2. So, question number 1 is if physical quantities can be measured, provide an example of a measuring instrument for one of the physical quantities you have studied. Dear students, you have to put an example of physical quantity and its measuring unit. So, the answer of this question is for measuring temperature, a common physical quantity, a thermometer is used. We are taking a common physical quantity here, that is temperature, and temperature is measured by thermometer. For example, in a laboratory setting, a digital thermometer can provide precise temperature readings quickly and accurately. You know, nowadays we are using digital thermometer that can precise that can provide precise temperature readings. Question number 2 is imagine a friend says that intensity of a smell should be a physical quantity because some smells are stronger than others. How would you respond to your friend's statement? The answer of this question is I would respond by explaining the intensity of a smell is subjective and depends on individual perception. Subjective meaning is we cannot measure the intensity of smell by any instrument. So it is not a physical quantity. Unlike physical quantities which are objective and measurable, physical quantities are objective and measurable. The meaning of objective is here any physical quantity which can be measured by using instrument. Chromatography and spectrometry are two techniques used to analyze the composition and concentration of substances. Composition means what kind of that smell is, and concentration means how much stronger that smell. So, including those contributing to smell, they do not directly measure the intensity of a smell. These are only two techniques, chromatography and spectrometry, but they do not directly measure the intensity of a smell. Okay, intensity of a smell means स्मेल की शिद्दत. ठीक है, तो ये इस शिद्दत को मेजर नहीं कर सकते. ठीक है, सिर्फ महसूस करने की हद तक है. Now question number 3 is if you were to measure the space inside a box, which derived quantity would you be finding? We have to find the volume to measure the space inside a box. The answer is to measure the space inside a box, we would be finding its volume. Okay, this answer is enough for this question, but if you add example, that would be more better. For example, a box with dimension of 2 meter in length, 1 meter in width, and 1.5 meter in height. You can take any other dimension that will be easy for you. You have to calculate its volume. So the formula of volume is length into width into height. You have to multiply all these dimensions. Let's suppose you have 2 meter in length, put length 2 meter, and you have width 1 meter, put 1 meter in width, and you have 1.5 meter height, and you have to put 1.5 meter in height. Now you have to multiply all these quantities 2 into 1 into 1.5, the answer will be 3, and meter into meter, that will be cubic meter. Okay, the answer is 3 cubic meter. Question number 4 is, suppose you are measuring how much light a bulb emits. Which base quantity are you working with? Answer is, when measuring how much light a bulb emits, working with base quantity of luminous intensity. The SI unit for luminous intensity is the candela. Question number 5 is, what are derived units and can you name one example? Derived units are units of measurement for quantities that are derived from combination of base units according to the law of physics. These units are formed by multiplying or dividing base units. You must have to put one example because it is mentioned in the question. So the example I have taken one example of derived unit, that is Newton, which is SI unit of force, and it is derived from the base units of mass. The unit of mass is kilogram, and acceleration, the unit of acceleration is meter per second square. So the force is equals to mass into acceleration. The unit of force is Newton and the mass is kilogram, and acceleration is meter per second square. So you have to replace it by units. Thus Newton is a derived unit because it combines the base units of mass and acceleration to measure force. Question number 6 is, why is the unit symbol for ampere capitalized? यूनिट सैम्बल फॉर एम्पेयर को हम कैपिटलाइज क्यों करते हैं? द यूनिट सैम्बल फॉर एम्पेयर विच इज़ ए is capitalized because it is named after a person. The ampere is named after Henri Marie Ampere, a French physicist and mathematician who made significant contribution to the study of electromagnetism. Ampere is named after Henri Marie, who is the scientist. So that's why it is the name of person. That's why the unit of ampere is capitalized. Question number 7. How would you represent the unit of force in terms of base units? In this question, we have to represent force in terms of base unit. So the unit of force in SI unit is Newton, which is denoted by capital N. Force can be represented in terms of base units as follows. 1 Newton N is defined as the force required to accelerate a mass of 1 kilogram at a rate of 1 meter per second squared. So 1 Newton equals to 1 kilogram meter per second square. Question number 8. List the rules for converting large and small numbers to scientific notation. So converting any large number or any too much small number to scientific notation is based on two rules. Rule number 1 is, a number in standard form is written as a into 10 raised to power n. It is the standard form. The a is a digit between 1 and 10, integer or decimal, and n is a positive integer for numbers greater than 1 or a negative integer for numbers less than 1. So n can be positive or negative. The rule number 2 is in standard form only only one non zero digit appears before the decimal point and the value is adjusted by multiplying by an appropriate power of 10. So one example is 1.3 into 10 raised to power 4. Question number 9. How do you multiply two numbers in scientific notation? Multiplying two numbers in scientific notation by multiply the coefficients and add exponents. So here is one example. There are two numbers in scientific notation. We have to multiply these numbers. The first rule is multiply the coefficients. There are 2 and 3 are coefficients of these scientific notations. So we have to multiply 2 and 3. The answer will be 6. The second rule is add the exponents. In this scientific notation, 10 raised to power 3 is exponent and in other scientific notation is 10 raised to power 4. So 3 plus 4. Answer will be 7. So after multiplying these two scientific notation, answer will be 6 into 10 raised to power 7. How would you correctly write a measurement of 20 megawatts per seconds? The answer is 20 megawatts per second would be written as 20 megawatt per second, like this. Question number 11. Express 5 square kilometers in square meters. To convert square kilometers to square meters, multiply by 1 million because there are 1 million square meters in 1 square kilometer. Look at here. We know that 1 kilometer equals to 1000 meter. So when we taking square on both sides, 1 kilometer square equals to 1 million square meter. There are 3 zeros and zeros will be doubled when we taking square. Okay, so in answer there are 6 zeros. So converting 5 square kilometers in square meters, multiply 5 by 1 million. We can also write 5 kilometer square multiply 5 by 1 million meters square. The answer will be 5 million square meters. Question number 12. In which scenario is random error more likely? First scenario is measuring the length of a table with a ruler, or second scenario is estimating the weight of a fruit by hand. So random error is generally more likely when estimating the weight of a fruit by hand, as compared to measuring the length of a table with a ruler. So, random error is more likely in estimating the weight of a fruit by hand. Question number 13. How can taking multiple readings help in reducing the impact of random errors? Taking multiple readings help in reducing the impact of random errors by allowing you to calculate an average or mean value. This average tends to be closer to the true value. When we take multiple readings after after that find its average. Sum of readings divided by number of readings. So this is the way that we can easily find its average. So the average tends to be closer to the true value. Question number 14. When an instrument consistently provides measurements that are higher than the true value, which type of error is most likely present? The answer is when an instrument consistently provides measurements that are higher than the true value, it is likely affected by a systematic error. Systematic error can be occur when an when there is flaw in an instrument. Question number 15. What does a consistent 5 grams more readings on a laboratory scale tell you about the precision and accuracy of scale? A consistent 5 grams more readings on a laboratory scale suggests that the scale has good precision but poor accuracy. Good precision means repeatability of measurements, and poor accuracy means closeness of measurements to the true value, but there is no actual value. So there is poor accuracy. Question number 17. Which instrument would be most appropriate for measuring the thickness of a thin wire? The most appropriate instrument for measuring the thickness of a thin wire would be micrometer. Screw gauge micrometers are precise instruments capable of measuring small dimensions with high accuracy, making them suitable for measuring the diameter or thickness of a thin wire. Question number 18. How can you identify a zero error on a vernier caliper? The answer is to identify a zero error on a vernier caliper by ensuring that the jaws or the measuring faces are closed together without any object between them. If the zero mark on the main scale does not align perfect with the zero mark on the vernier scale, a zero error is present. Question number 19. What is the advantage of using a tape measure over a ruler? The advantage of using a tape measure over a ruler is its flexibility and length, allowing it to measure longer and curved surfaces more easily, like trees in a forest. You can also take any other example like length of a door, etc. Question number 20. Why might you choose a vernier caliper over a micrometer for a specific measurement? Answer is because vernier calipers can measure both internal and external dimensions as well as depths, making them more versatile. They also provide a wider range of measurements, while micrometers are typically more precise but limited to measuring smaller ranges and usually only external dimensions. Question number 21. Why might digital timers be preferred over traditional clocks in some laboratory settings? Digital timers might be preferred over traditional clocks in laboratory settings because they offer greater precision, ease of use, and the ability to measure specific intervals accurately. So, digital timers more preferred. Question number 22. What is the significance of the zero or reset button on a digital timer? The significance of the zero or reset button on a digital timer is to quickly reset the timer to zero, allowing for accurate and immediate timing of new events or experiments without any delay. Question number 23. What are significant figures and why are they important in rounding off calculational estimates in empirical data? Here in this question, you are finding what are the significant figures and why they are important. So, significant figures represent the meaningful digits in a number that convey the precision of a measurement or calculation. They are important in rounding off because they indicate the level of certainty or precision of the measurement. When when rounding off calculations, maintaining the correct number of significant figures ensures that the final result reflects the accuracy of the original data and avoids misleading interpretations due to excessive precision. Question number 24. You have a measured value of 12.345 and you want to round it to three significant figures. What will the value be and how do you justify rounding? Rounding rounded to three significant figures, the value 12.345 becomes 12.3 because there are three significant digits 1, 2, and 3, and after 3 there is number 4 which is less than 5, so 3 remains same. This rounding is justified because we consider only the first three significant digits, ignoring the less precise digits that follow, thus reflecting the accuracy of the original measurement. If you find this video useful, then like it and share it with your friends. And if you want its PDF file, then let me know in the comment section. Don't forget to subscribe my channel because it motivates me to make more videos regarding your interest. Thanks for watching.